Hello everyone, my name is Saeed Faroud Al-Hajri.
I am Saif Al-Momani.
And we are from 11C. Today we will be talking about electrolysis and how we can apply it. We will discuss how electrolysis can help remove heavy metals and other pollutants from wastewater. We have a bunch of learning objectives, some of it being how to understand how electrolysis can remove heavy metals and other pollutants from wastewater, and to investigate the impact of different anode materials on pollutant removal efficiency. Now we have a lot of complex items here, and as you can see the experiment seems complex, but we will help and break it down for you. First of all, we have the power supply that is there, which supplies 12 volts. We have the ammeter, which will help give us a reading of the current, and the voltmeter, which will tell us how much of the electricity is moving. We have the simulated wastewater, which will help show us exactly how electrolysis will work. And then we have the two main items in the experiment, which is the anode and the cathode. Cathode being the steel, anode being the graphite. And then we have our conductivity meter, which will help give us a reading of the current. And then we have our pH sensor, which will help us give us a reading of the pH.
I'm Saif from 11C. As you know, we're working on the project Electrolysis Application of Electrolysis. For the introduction, we're leading a global oil and gas producer as numerous refineries and petrochemical plants. One such company can be the Qatar PetroChem. This is a problem because it can be a conventional wastewater treatment methods have been insufficient to deal with the specific contaminants present in petrochemical wastewater. As a proposed solution of this, it can be the Qatar PetroChem. This is considering implementing an advanced electrolysis system to enhance its water treatment facilities. We will work further on this project and hope to find a solution.
One of the main learning platforms that we have depended on is called Gizmos. Gizmos is a learning platform that is mainly used in the school, and we have used it as an inspiration for our case studies. Many of our applications and methods that we have used in this experiment has been inspired and taken from Gizmos. Based on the Gizmos case study, electrons and chemical reactions, our 11C class worked on zinc plating and learned on the redox reaction before we moved to the electrolysis process. The Sustainable Development Goals, SDGs, that are most relevant to our project, focusing on the exploration of different anode materials, at least graphite in this investigation, for improving the efficiency and effectiveness of electrolysis in treating industrial wastewaters, include SDG 6, which is clean water and sanitation. This goal, and SDG 9, which is industry, innovation and infrastructure. As you can see here, during the process of electrolysis, we can see that most likely oxygen gas is all gathering at the anode, which is the graphite, and we can see copper deposits at the cathode, which is steel. The analysis of the experiment readings were many, but some of the main and most important readings were, first of all, the pH changes, where the initial pH starts at 5.2 and varies significantly over time, reaching a maximum of 10.1 at 10 minutes before stabilizing and decreasing. These fluctuations in pH might indicate chemical reactions that produce or consume hydrogen ions at different stages of the electrolysis process. Conductivity. The initial conductivity started at 780 and remains fairly stable with slight fluctuations, suggesting consistent ion concentration in the solution. Minor changes in conductivity indicate the movement of ions, but there was no major depletion or accumulation within the experiment's time span. 3. Current. Initial current consistently at 0.125 amps at the start, indicating stable current flow, and slightly decreases in current, which is less than 0.125 amps towards the end, possibly due to electrode surface changes or ion concentration variations. And 4. Observations at electrodes. Anode bubble formation starts at 5 minutes and becomes steady, indicating oxygen gas production. And as for the cathode, visible copper deposits from early on, with the thickness increasing over time, demonstrating the reduction of copper ions.